Okay, so here's the formula. So here's something that you need to wrap your mind around, and that is that the number of moles of solute that you have pulled out of your initial solution is going to equal the number of moles of solute in your final solution. Okay, there's no increasing or decreasing the amount of solute. So the number of moles of solute are going to be the same, okay? They stay consistent. So therefore, if the initial number of moles is equal to the final number of moles, then, and the number of moles is equal to the concentration times the volume. Therefore, we can say that the concentration times the volume of the initial solution is equal to the concentration and the volume of the final solution, okay? So again, these things are in your data booklet, so the formula, okay, and what those things are in your data booklet, okay? And I have a data booklet right here, and they're right under all the formulas that we've already been using, or sorry, they're right in the middle here, so on page 10. Okay, this is the formula here that we're dealing with, and all of those things here. Now, there's this note here, and it says that the initial volume is always smaller than the final volume, and the initial concentration is always larger than the final concentration. I don't really necessarily like that. The thing that you need to keep in mind for me is that you're just making sure that the concentration and the volume that you are given in the question that refer to the same solution need to either be initial or final. They need to go together, okay? So if that's a little harder for you, then you can always remember this, that the initial volume should be smaller than the final volume, and the initial concentration should always be larger than the final concentration. The reason for this is if both sides of that equation need to equal each other, okay, then as one value goes up, okay, in an equation, the other value must go down in order to keep that number the same, okay? And that's something that's like a concept based on formula. Sorry. Okay, that's a concept based on that type of formula that you need to understand, okay? So just that as the concentration on one side increases, then the volume must decrease if we're talking about the same number on the other side, okay? So if, for instance, my initial concentration and volume is equal to 1, then as my volume increases, the concentration must decrease so that the value is equal to 1, okay? It's something that comes up a lot, and understanding that sort of inverse relationship. So as one goes up, the other one must go down. So that's something to keep in mind here.